Figures 912 through 914, CommissionEmployee3.java, base plus CommissionEmployee4.java, and base plus CommissionEmployee test4.java. In this last version of the Commission Employee base plus Commission Employee hierarchy, we are aiming for the best possible software engineering, which also has other side effects such as making your code easier to debug, modify, and maintain as well. And we'd like to focus on all of those concepts as we look at this last version of the hierarchy. So first thing, you'll notice we have a new version of class CommissionEmployee3, and we have gone back to using private data rather than protected data. You might look at protected data as breaking the so-called encapsulation of your class. If you allow any class outside of the class that originally defines the data to have direct access to that data, then you are breaking that class's encapsulation, and you're also making your code harder to debug, modify, and maintain. If you know that your data is private to your class, then first of all, since only your class can actually access the data directly, if something goes wrong, it's easier to figure out where to debug the code that is manipulating your pieces of data. That would have to be in your class, inside of your methods of your class. On the other hand, if your data is protected, then it's possible that the problem could happen in your class or in any subclass of your class throughout the class hierarchy, because once you declare data as protected, every class from that point forward in the hierarchy has direct access to the data. Similarly, in terms of maintaining and modifying your code, if you have to make a change to the internal details of your superclass. Maybe you need to rename a variable or change the set of variables. If all of the variables are private to your class and encapsulated within the objects of your class, then subclasses and client code have no idea what the physical implementation details are for your class. But if you make your data protected, then the subclasses do have direct knowledge of the implementation details of the superclasses, and if the superclass details change, the subclasses may need to be recoded as well. So to protect yourself against future change, it's always best to use private data whenever possible. So we've gone ahead and changed all of our data back to private. We still have our constructor to initialize the data in this class and our full complement of set and get methods for manipulating the data. Another key change that we made to this class comes inside the earnings method, where instead of using commission rate and gross sales instance variables, we are using the actual get methods, get commission rate and get gross sales. And by doing this, we are again protecting ourselves against the possibility of future change. If for some reason we needed to modify the names of the underlying variables or change the data representation completely, but we still have these get methods, then the earnings method would be protected against future change. And the same is true even here in the toString method, where we are now using get methods to obtain all of the values of our instance variables. In this way, if anything has to change with regard to the names of those variables or potentially the overall structure of the data inside an object of class CommissionEmployee3, this method also is protected against changes like that. Also, now that we've got this updated version of class CommissionEmployee called CommissionEmployee3, we've modified the base plus CommissionEmployee class to create the fourth version of the class, which now inherits from the third version of class CommissionEmployee3. And because it extends CommissionEmployee3, the data in class CommissionEmployee3 is private, and therefore to access the data we will use get methods inside the body of this class. So in addition to the 5 pieces of private data in class CommissionEmployee3, a base plus CommissionEmployee4 also has the base salary. Once again, you can see the constructor being used to initialize 5 of the members by calling the superclass CommissionEmployee3 constructor, and then set base salary to set the base salary on one of our objects of this class. Our set and get base salary methods are identical. But let's take a look at the earnings method, which has another new feature. If you think back, actually, if you look back at class Commission Employee 3 and how the earnings method is set up, it calculates commission rate times gross sales for us already. And part of what we need to do in class Base Plus Commission Employee 4 is exactly that calculation. And then we need to add to that the base salary for the Base Plus Commission Employee worker. So we're calling get base salary to get an object of this class's base salary, and we're adding to that super.earnings, which says don't call this earnings method, but go back to the superclass Commission Employee 3 and use its earnings method to determine the gross sales times the commission rate. Once that happens, we'll add that to the base salary, and together those will represent the complete earnings for a Base Plus Commission Employee 4 object. And in a similar fashion, if you look at lines 37 through 41 here at the toString method, super.toString, which is the commission employee class's toString, already is capable of producing a large portion of what this toString method should produce as the string representation of a Base Plus Commission Employee 4 object. So what we're going to do here is output the words base salaried followed by the string representation that was defined in class Commission Employee 3. If we go look at that string representation, it will include the words commission employee, the first name, the last name, the social security number information, the gross sales information, and the commission rate information. And then we're going to go back to this toString method, and we're going to output at the very end, as part of the string representation, the base salary and the value of that base salary. So as you look through the Base Plus Commission Employee 4 class definition, you'll see that in as many places as possible, we use get methods or set methods to access and manipulate the data rather than directly accessing the variables. Of course, in methods like set base salary and get base salary, you have to access the underlying instance variables, and those are the types of methods where if you inside the body of a class can guarantee that the only place you set a particular variable is from its corresponding set method, and the only place you get a particular variable is from its corresponding get method, then you can greatly simplify the process of debugging your code, because only those methods would be responsible for manipulating the underlying data. And then in the future, if you do need to modify the implementation level details, such as your data representations inside your objects, you may only need to update the bodies of your set and get methods, as opposed to possibly lots of other code in your class and in the subclasses of your class as well. So in this final version of the hierarchy, we've got a Commission Employee 3 class with all private data. The Base Plus Commission Employee 4 class extends that Commission Employee 3 class and even goes so far as using methods that we've inherited and redefined. We call that overriding, so that we can get a portion of the functionality from the superclass. And this concept of overriding methods becomes extremely important as we move forward into our lesson on polymorphism. It's one of the key aspects that enables the concept of polymorphism. And by the way, one last thing on redefining a method: it is very common when you redefine an inherited method to invoke the superclass version of that method to perform part of the new method's task.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.